Hello, I am Gopundra. Welcomes you on to the second session of the chapter quadratic equation on behalf of the invariant mathematics. So, as you know, in the first session I discussed about the quadratic formula, which is given by x is equal to minus b plus minus root over of b square minus 4ac divided by 2a, where b square minus 4ac is known as discriminant denoted by d. So, according to the value of d, the nature of the roots of the quadratic equation depends. Now, first one is if d is greater than 0, means d is positive, then the roots are real and distinct, Second, if d is equal to 0, then the roots are real and equal. Number 3, if d is less than 0, then the roots are imaginary. That means there will be no real root. Imaginary means there will be no real root. This concept is very important as far as the exam is concerned. So this concept is nature of the roots of quadratic equations. As we know, the general form of the quadratic equation is ax square plus bx plus c is equal to 0, and the roots are given by the formula x is equal to minus b plus minus root over of b square minus 4ac by 2a, where b square minus 4ac is known as discriminant or denoted by d. According to the value of d, the nature of the roots of the quadratic equation depends. If d is greater than 0, then the roots are real and distinct. If d is equal to 0, then the roots are real and equal. If d is less than 0, then the roots are imaginary or no real root is there. Now, how we find the nature of the roots? Take some examples how we find the nature of the roots. Number 1, suppose it is given 2x square plus 3x plus 5 is equal to 0. If we compare it with the general form of the quadratic equation, here we get a is equal to 2, b is equal to 3, c is equal to 5. Now, b square d is equal to b square minus 4ac, which is equal to 3 whole square minus 4 into 2 into 5, that is equal to 9 minus 40, that is equal to minus 31. As minus 31 is less than 0, therefore the roots are imaginary. That means we get no real root. Like this, we can find the nature of the roots of any equation. So now comes to its application. According to the condition of nature of the roots, the application is very important. Suppose it is given as if roots of kx square minus 6x minus 2 is equal to 0 has real roots, then find k. So here it is given as it has real roots. Here it is not mentioned that the real roots are distinct or real roots are equal. So in case of only mentioned real roots, we have to take the two conditions. In that case, as the equation has real roots, so d is greater than equal to 0. D is greater than equal to 0. D greater than 0, it is real and distinct. D equal to 0, it is real and equal. Implies that b square minus 4ac is greater than equal to 0. Implies that. Now compare this equation with the general form, so that we get a is equal to k, b is equal to minus 6, c is equal to minus 2. So b square means minus 6 whole square minus 4 into k into minus 2 is greater than equal to 0. Implies that 36 plus 8k is greater than equal to 0. Implies that 8k is greater than equal to minus 36. Implies that k is greater than equal to minus 36 by 8, that is equal to minus 9 by 2. So this is the required value of k. K is greater than equal to minus 9 by 2. Now comes to the second example. The applications are very important in this case. If roots of k plus 4 whole into x square plus k plus 1 whole into x plus 1 is equal to 0 are real and equal. Real and equal, then find solution. First, this is the quadratic equation given. So compare it with the general form ax square plus bx plus c is equal to 0. So that a is equal to k plus 4, b is equal to k plus 1, c is equal to 1. So as the roots are given as real and equal, so according to the condition b is equal to 0, implies that b square minus 4ac is equal to 0. Implies that k plus 1 whole square minus 4 into k plus 4 into 1 is equal to 0. Implies that k square plus 2k plus 1 minus 4k minus 16 is equal to 0. Implies that k square minus 2k minus 15 is equal to 0. Implies that k square minus 3k plus 3k minus 5k minus 15 is equal to 0. Implies that k whole into k plus 3 minus 5 whole into k plus 3 is equal to 0, which implies that k plus 3 whole into k minus 5 is equal to 0. So when this factor is equal with 0, it gives k is equal to minus 3. When the second factor is equal with 0, 0, it gives the value k is equal to 5. Therefore, the value of k is -3 or +5. Like this, we have to apply the conditions, nature of the roots. Now comes to third example. How we prove any problem? Suppose if it is given as 1 plus m square whole into x square plus 2mcx plus c square minus l square. The quadratic equation has real and equal roots. Real and equal roots. Prove that c square is equal to a square whole into 1 plus m square. So now the quadratic equation we compare with the general form. This is true. So when we compare with the general form, a is equal to 1 plus m square, b is equal to 2mcx, c is equal to c square minus s square. As it is given, the quadratic equation has real and equal roots. So b is equal to 0. Implies that b square minus 4ac is equal to 0. Implies that 2mc whole square minus 4 into 1 plus m square into c square minus a square is equal to 0. 4ac is equal to 0. Now it gives 4m square c square minus 4c square plus 4a square minus 4m square c square plus 4m square a square is equal to 0. If we simplify it, now 4m square c square, 4m square c square cancelled, which implies that minus 4c square plus 4a square plus 4m square a square is equal to 0. Implies that 4a square plus 4m square a square is equal to 4c square. By taking 4a square common, we get 1 plus m square is equal to 4c square. Now 4 cancel, which implies that c square is equal to a square whole into 1 plus m square. This is the proof part. C square is equal to a square whole into 1 plus m square. Now comes to another example based on this nature of the roots. If minus 5 is a root of, if minus 5 is a root of 2x square plus px minus 15 is equal to 0, and p whole into x square plus x plus k is equal to 0 has real and equal roots. Real and equal roots. Find k. In this question, if you consider this question, there are two steps. First step is minus 5 is a root of this one, from where you have to find out the value of p. Then putting the value of b, this comes a quadratic equation, and you have to put the condition. Now, solution. As minus 5 is a root of 2x square, minus 5 is a root of 2x square plus px minus 15 is equal to 0, implies that 2 into minus 5 whole square plus p into minus 5 minus 15 is equal to 0, implies that this is 50 minus 5p minus 15 is equal to 0. If you solve it, you will get p is equal to 7. Now after finding the value of p, put the value of p in the second one. So the quadratic equation, the second quadratic equation becomes 7 into x square plus x plus a is equal to 0, implies that this is 7x square plus 7x plus k is equal to 0. This is your quadratic equation. Now here it is given that this quadratic equation has a real and equal roots. Therefore b is equal to 0. That means b is equal to 0, implies that b square minus 4ac is equal to 0, implies that. Now compare this equation with the general form, ax square plus bx plus c is equal to 0. So a is equal to 7, b is equal to 7 and c is equal to k. Now put the value. 7 square minus 4 into 7 into k is equal to 0, implies that 49 minus 28k is equal to 0, implies that 49 is equal to 28k, implies that k is equal to 49 by 28, that is equal to 7 by 4. Therefore the value of k is 7 by 4. Now there are two steps in this question. This type of question you will make two steps. From first step you have to find out the value of p. From second step you have to apply the nature of the roots to find the value of k. Now this is all about today's session. You please do like, share, subscribe and my YouTube channel Invarient Maths. So be in touch with me. If you want to be regular in touch with me, you can call me and you can touch with me through Next Gen Education, Bangalore, Thank you.